So today I'm going to cover a bit of about classes, the bit that it's about inheritance. So first let's introduce the notion of inheritance. For example, you have cars in general, and then you have limousines and minivans, right? So cars in general, they have four wheels for the most part. They have a steering wheel, they have seats. The number of seats varies, but they have seats. They have color, maximum speed, MPG, windows, etc., etc. There's a lot of commonalities that are proper to a car that are shared by limousines and minivans. Now there are differences though. So all car doors open, but back doors slide on minivans where they like flap open in a limo. There might be a hatchback on a minivan versus a trunk on a limo. Minivans has options like back row DVD. Not every car has those. And then on top of that, the limo might have a minibar, phone, and internet, and many others. So there are many things that are common to cars, but distinguish limousines from any other car and distinguish limousines from minivans. Okay? So if you were to represent limousines, minivans, and cars, you'd be creating a limo class and a minivan class and a car class, and it'd be silly to repeat everything they share because it's a lot, methods and variables. Instead, a minivan can inherit from a car, and a limo can inherit a lot from a car too. So car can be what's called a superclass, and then for minivan and for limousines, you just code what's different, what's fundamentally different. Another quick example, for example, is a turtle inherits a lot of properties from a reptile, right? And so does snake, but a turtle and snake, they don't inherit from each other. And then in turn, reptile might inherit a lot from an animal class, a lot of properties and methods, right? So all of them eat, all of them walk, or all of them move. Now some walk, some don't, etc. That is the concept of inheritance. You have an object that is a kind of apparent object. So for example, the limousine is a car. A minivan is a car. A minivan, however, is not a limousine, right? So whenever you have an is-a association, then you have an inheritance case. Okay, a turtle is a reptile. A turtle is not a snake. A reptile is an animal, right? Now, we'll see how, and then of course the turtle is a reptile and a reptile is an animal, so we can say that turtle is also inheriting from animal. Okay, so if there's transitions to get to even higher and higher and higher parent class, well, the lower class, the one that is always inheriting from the ones above it, from that hierarchy. So let's do a quick example here with rectangles and squares. Because, so for example, I've created a class here called rectangle no inheritance, which is basically a rectangle, right? It has an int area, which can be completely avoided, but it has a side A and side B variables. You have a set side A and set side B. You have a get area, which is side A times side B. You have a get perimeter, which is 2 times side A plus 2 times side B. And then you have a toString, which says rectangle side A by side B, so rectangle 3 by 5 or whatever, right? The same way you have a class square no inheritance. The square no inheritance has a side, a set side, a get area, which is side by side, and a get perimeter, which is 4 times side. And it can also have a toString method, right? So public string toString square of side and then side. You can always toString method. And sorry, this will be a return. All right, so we have a toString method in this. We have a lot of code here potentially, and a lot of code for the rectangle. Okay, so let's have a test shape class that will test these things. So I've commented out portions just to make the video a little easier and less typing on your side. And let's see what I have here. let's go line by line. So what I have here is, first I'll create a rectangle no inheritance called rec. It's going to be of side 3 by 4, and I will print line. Rectangle area is, we expect 3 by 4, we expect 12, and rectangle perimeter, we expect 6 and 8, we expect 14. Then I've created a square no inheritance, right, of side 3, and then we expect the area to be 9, and the perimeter to be 4 times 3, 12. Okay. So let's just run this. Let's compile. It's saving and compiling. And then let's run it. And let's see if we get what is expected. So our classes are working fine. We have a rectangle area for 12, perimeter 14, square area 9, perimeter is 12. And then let's do something next. Let's try now to get an array of rectangles and squares, for example. Let's try to get this. So we have a rectangle no inheritance array, right? Rectangle no inheritance is going to be of size 4. We'll create rectangle 1 with side A and side B, rectangle 2 with side A and side B, rectangle 3 with side A and side B. Here are a couple of things to notice. These two here are squares because they have the same sides. So then we put them in the array. Array sub 0 is rec, the one that we created first, and then the other 3 we put in the other 3 positions of the array. But we're putting 2 here that are squares, but we cannot use the square object because this array is only for rectangles. Okay? And then we'll just print this rectangle. So compile and then print. So if we wanted to have several shapes here, and here it is, rectangle 3 by 4, 2 by 3, 3 by 3, and 5 by 5. As you notice, the last two are actually squares. But because of this restriction, the array must have rectangle elements. We cannot put a square element, which would be more appropriate for this. Okay? We'll have to do everything in terms of rectangles. No matter if we created the square class, it doesn't help us at all for this type of problem. Okay? Now let's look at inheritance and how that's done in the Java language. I've created a class rectangle here. And this is just rectangle. I'm going to use inheritance here, but rectangle is a mother class. It has side A and side B. It has all the methods, right? Set side A, set side B, get the area, get the perimeter, and then the toString method. It has everything. Now I have created a square class, which is slightly different than the other one. Let's say square extends rectangle, meaning it gets all the variables that are public and protected from rectangle, as well as all the methods that are public and protected from rectangle, and knows them and can execute them, inherits them. So all I need to do here is, for example, a set side method with a side in which I tell it side A is S and side B is S, because square is a rectangle. Square already has a side A and side B variables. It also has a get area method and a get perimeter method, which are defined by the rectangle. I don't need to redefine those methods here, because as soon as I set both sides the same, then all the other methods work. The only one that I will actually override, and this is method overriding, is the toString method. Before it was rectangle of whatever by whatever. Well, I'm just overriding it to say square of side something. Okay? So now, so you understand, I'm adding a method here by using variables that I've inherited, and I'm also overriding a method. So that meaning that I'm writing the same method, but it's going to be unique to the class square. Okay? That's overriding. Now let's go to our test shape here. Let's come into that code. And here what I'm going to do is I am going to do the same thing. I have a rectangle, new rectangle with side 3, side 4 is the exact same thing as before, and then I'm creating a new square, side 3, and you will see the exact same output as before. So rectangle, area 12, perimeter 14, and square area 9, perimeter 12. It worked exactly as it worked before. But here's a pretty interesting conclusion too. I'm going to create a rectangle array. You can put any element that is a rectangle. It's going to be 4 elements, right? So we create the first rectangle with side A and side B. We have another rectangle here that I'm going to put in the array. And now we have squares here. Square, another square is SQ1, okay? Now remember, square inherits from a rectangle, therefore a square is a rectangle. So I can put a square in this array because this is an array of rectangles, and squares are rectangles because they inherit from it. They extend rectangle. So I can just put my array like this: 0, 1, 2, 3, and rectangle, rectangle 1, square, square 1. Just like that. And then I'm just going to call the system.out.println, right? I'm going to call the toString method of whatever is in this array. If it's a rectangle, it's going to call the rectangle toString. If it's a square, it's going to call the squares toString. So let's compile this and run it. Whoops. Compile, continue, run. Okay, let me compile it again and run. And now you see rectangle 3 by 4, rectangle 2 by 3, and then square of side 3 and square of side 5. So it's actually getting the square property. So what happens here is really interesting. Not only the square saved us a lot of code, because in my square class I only coded one method and overload another. I didn't have to set side, get area, get perimeter, get all those other things that work exactly the same as a rectangle. All right? So it's less code. And also, it allows me to actually create a collection of the superclass of rectangle, for example, and put any subclasses that I want in there. Okay, so for example, you can think of modeling several animals or several kinds of employees in a company or several animals in a zoo, and then having an array called zoo or have an array called company where I just put those elements. If I don't use inheritance, I cannot do this because without inheritance, the elements of an array or any other place where I need diverse elements is not going to work. With inheritance, if those diverse elements inherit from a common class, I can actually they can sort of interchangeably work together. We're going to see more about this later, but this is just the basics of inheritance.